this one's kind of a tricky problem here. The first part's not that bad. What's the range of stakes? The smallest number we have is 8. The biggest we have is 15. So when we find the range, we find the max minus the minimum. That gives us 7. The average weight of the stakes, I took the liberty of putting it into the calculator already so I can hit enter and say I'm going to divide that by, that's a 5 by 3, so I'm going to divide by 15. And that's 11. So my average is 11. Okay. So when we talk about which number best approximates the standard deviation, if you're given something like this, you're going to want to think about what makes logical sense. Okay. You have a middle from 11 with a range of 7. That means it goes up above it by close to 3.5 and down below it by about 3.5. And specifically, the biggest number above is 4, and the smallest number below 11 is 8, which is only 3. So it goes up 4 above and 3 below. So if we understand the standard deviation, if we're approximating here, standard deviation is the average distance from the mean. So we have this big number, 5.3. The average can't be 5.3 if the greatest distance away from this is 4 above and only 3 below. So we couldn't have an average that was that big. Also, standard deviations will never be a negative number. So the question boils down basically logically to a very small standard deviation or a standard deviation in the neighborhood of 2.4. Again, if we have a mean of 11 and we have things that go up as high as 15, 14, and down as low as 8, a number of them that go down as low as 8, the best approximation for the average distance from the mean, and we actually don't have any 11s, so there's no numbers that are going to be extremely small. We have a handful of 10s, a handful of 12s, so those are 1s, but we have other things that are going to be driving the standard deviation up. The only one that makes the most sense in the world is this one here. And so the last question about this problem in number 8, where it says, in order to maintain consistency, the restaurant's manager only accepts steaks with weights within 1 standard deviation of the mean. The smallest size steak that the managers will accept if they want to stay within 1 standard deviation of the mean, well, remember, standard deviation can be above or below. So if we took 11 and we added and we subtracted 2.4, we could get kind of a range of values that give us that approximate the weight. Okay, so that means within 1 standard deviation we'll go up as high as, if we add 2.4, that'll be up as high as 13.4, but it'll also go down as low as about 8.6. So this is a range of values that go from big to smaller, from small to big, however you look at it. But it said, what is the smallest one that they would accept? Well, we don't want to go down to 8, because 8 would be more than 1 standard deviation below. So acceptable would be a 9. A steak with a size of 9 would be on the low end, but it would still be within 1 standard deviation of the mean of 11. So if we can understand that a standard deviation is an approximation that goes above and below, and that's the smallest one that they would accept. The biggest one that they would accept within 1 standard deviation is going to be 13.4, because it's still within if you look at the 13. Whereas in this case here we had to do the 9, which was the biggest number that was within 8.6, that at least it's on this list.